All right, AP Stat, let me take you through one last new thing. So we're going to just extend pretty much what we did the other day using logarithms to transform data. So here is our problem. Um, Imagine that you have been put in charge of organizing a fishing tournament in which prizes will be given for the heaviest Atlantic Ocean rockfish caught. You know that many of the fish caught during the tournament will be measured and released. You are also aware that using delicate scales to try to weigh a fish that is flopping around in a moving boat will probably not yield very accurate results. It would be much easier to measure the length of the fish while on the boat. What you need is a way to convert the length of the fish to the weight. You contact the nearby Marine Research Laboratory and it provides reference data on the length in centimeters and the weight in grams for Atlantic Ocean rockfish of several sizes. Here is the scatter plot of the data. Note the clear curved form, and so we've got curved data once again. And by the way, this problem is on page 797 in your textbook if you want to check it out there and see it kind of written out. All right, so ultimately we just got that data. We've got curved data, so we're going to get that data in particular and get it into our calculator. And so that's what I've done here. And maybe I'll ask you to pause and go ahead and do that yourself if you want to do this alongside with me. Notice there are two rows of data. So we've got the 5.2 a little bit. The 5.2 goes with the 2, and then eventually I get down to like this 28.2 for that second row goes with 318, and so ultimately we have 20 data values. So we should have 20 pair, I guess, data pairs. All right, so we go to look at our graph of this. So L1, L2, scatter plot, zoom 9, and so we should see pretty much their curve, right? I've just graphed it myself just to verify that that's what it looks like. All right, so obviously a line is not going to be a great fit. If I take the time to do that real quick, L1, L2, we get a correlation. I mean, again, that correlation looks strong, 90.94. So again, we can't trust the correlation alone. So if we did, that just created a list of residuals. If we look at our residuals, a residual plot, no, that's no good. And ignore the line. I don't know what I'm doing there. All right, so that's no good. Well, we think, all right, maybe we'll try the thing that we learned on Monday or Tuesday, and that is to take the logarithm of all the y values. So I'm going to take the logarithm of all my L2 values and maybe store those into L3 and follow that process. And so maybe I can make a plot of L1 and my logarithm of my y values. And so we try that, and okay, it changed it, but it doesn't look super linear, right? And so we can check and see, calculate linear regression on this new L1, L3, this x and log y. But okay, correlation creeped up a little bit, which is great. But as we can see, and we could see it was evident before. But if we look at a residual plot, it's curving. It's actually curving the other way now. But exponential was too much. So this is not exponential data. And so you might think about the data itself. We're getting a weight from a length. Would that be exponential or some other model? All right, so what we can do with this data in particular is I'll show you the theory behind this in the next video, but let's go ahead and take the logarithm of both lists. All right, so I'm going to take the logarithm of list 1, and I'm going to store that into L3. All right, so it took the logarithm of all my x values. And then I'm going to take the logarithm of list 2 and store that into L4. So we've taken the log of our x's and the log of our y's, and they're in L3 and L4. And maybe I'm going to make a note of this because this is starting to get kind of crazy. So remember, in my x list, my x's ultimately measure lengths. Length, LNGTH, in centimeters, and then y is our weight, and that was in what was that in? That was in grams. So in grams, sorry. All right, and so that I have in x is in L1, and then this is in L2. And so now in L3, I have the logarithm of my x values, and in L4, I've got the logarithm of my y values. All right, because this can be easy to not, to keep straight. So now let's look at the relationship between my my L3 and L4 now. L3 and L4, and zoom 9. And, oh, magically, all right, now that's a straight line. So apparently there's a linear relationship between log x and log y. So let's take a quick peek. Stat calculate linear regression between my L3 and L4, my logarithm of my x's and my logarithm of my y's. I might even go ahead and store that regression equation, variables, y variables, function y1. Not, you could type it in by hand, right? You can type in this a and that b. But we get this prediction equation, and check out that correlation coefficient. Now we're there. We got a nice, strong linear relationship between the logarithm of x's and the logarithm of the y's, which means this data didn't have a linear relationship, but we'll ultimately get back to seeing what it was. All right, so I'm going to jot down that equation that I just got, and it says y, but I know it's actually log y. So log y is equal to negative 1.89934. And I'd say go to quite a few decimal places on these, because as we exponentiate on 10, we put the 10 to these powers. The more accurate you can be, the better. You can end up quite a bit off if you round that to just, the tenth place or something like that. All right, and so then we have plus, and then so my b is 3.0494. And then it says x, but I know that was actually log x. So that's times log x. And so at this point, I'll throw a hat on there. We actually have a prediction equation that we could use. And so we could use this that linear relationship, and we can look back at here. It got plugged in, and so if I go to graph it, we see that line fitting that. And while we're on it, let's check and make sure it is a good fit. You can obviously tell that it looks pretty good, but we could check our residuals, and so we would actually leave it L3 and resid to look at our residual plot. And so yeah, that's pretty good. All right, that's a pretty messy plot. So we're good there. So it does seem like there is a linear relationship between those log x's and log y's. So if we wanted to then make a prediction for a particular length of fish, we could do so. So let's not extrapolate here. We did that last time, which we know is risky. It can be off. So let's actually do interpolation, a prediction within our range. So let's make a prediction for one that is, I don't know, what's a number we didn't use, 30, I don't know, 35.5. I don't know, that's not on any of those measurements. So let's plug in, we got a fish that is 35.5, centimeters long. So we can make that substitution. So, basically we type it in just like this. So it is, we'll type in the right side, and this at this point it should be pretty similar to what we did before, only we got a log on the right side too. So negative 1.8994, negative 1.8994 plus 3.0494, and then log x. So log of x, and I decided to plug in 35.5. All right, and so I get that log y equals that. Log y is 2.8279, I guess. And so then we can finish solving this, either change it exponential mode or exponentiate on 10, right? 10 to the log y equals 10 to the 2.8279. That cancels. We get y is 10 to that number. 10 to that number. 672 grams would be our prediction. So 672.77 grams. And so there we can use that to get a prediction. We also could have typed in, we could have done the thing where we go variables, y variables. We could have done y1 of 35.5 since I have it plugged in, and it would give us, right, that's not working because it's not the linear. So yeah, actually, don't just do the y1 thing because that's just doing x. It's not doing the logarithm of that x because my prediction equation doesn't know that that's what we're working with. All right, so but then we can if we can use that to make our prediction of a y from x. So in the next video, I'll show you why that works and also how we can take that equation and get it back into what the actual shape is for this data. But we can, at this point, make predictions using the relationship between log x and log y. So on to the next video.